When you picture Kashmir, it's easy to just think of these breathtaking mountains and beautiful, serene valleys. But just beneath all that beauty, there's a region living on a knife's edge. It's facing a really dangerous convergence of threats, one that's coming from deep inside the Earth and another one from high up in the atmosphere. And understanding this dual crisis is absolutely critical.
This quote from environmentalist Raja Muzaffarbat, it just gets right to the heart of the problem. It's this incredibly stark warning that the disasters we're seeing right now, they're not just random one-off events. They're actually a preview of a much, much bigger crisis, one where our own human activity is pushing a fragile ecosystem right past its breaking point.
3.5 million. Look at that number. And you've got to understand, this isn't just some abstract statistic on a slide. That's the number of people who were left without a home after the massive 2005 earthquake. They were forced to face a brutal Himalayan winter with nothing. This, right here, this is the real human cost when the ground underneath Kashmir decides to move.
Okay, so this brings us to the crucial idea here. Kashmir is caught in a dual catastrophe. It's essentially fighting a war on two fronts against these immense natural forces, one from the shaking ground below and the other from the volatile sky above. And as we're about to see, these two threats are dangerously connected.
So let's start with that first threat, the shaking ground. You have to understand, for Kashmir, a major earthquake isn't a matter of if, it's a matter of when. It is a geological certainty. The very land itself is defined by this constant, powerful, and totally unavoidable tectonic reality. Now you'll see this classification, IS Seismic Zone 5, and that's not just some technical jargon. That is the highest possible risk category in India, period. Kashmir is sitting directly on the collision course where the Indian and Eurasian tectonic plates are literally crashing into each other. It puts the whole region on a permanent red alert for a really catastrophic earthquake.
And listen, this is not some new threat. The evidence of massive quakes is literally carved in stone. You can see it in ancient temples that showed displacement from quakes centuries ago. But the 2005 earthquake, that was a massive magnitude 7.6 event. It was a brutal modern-day reminder of the incredible power that's just lurking right beneath the surface.
19,000. Just let that number sink in for a second. It's absolutely heartbreaking. That's how many students died in Pakistan during that 2005 quake. And the reason? Their school buildings, the very places that should have been safe, were so poorly built that they just crumbled. This wasn't just a natural disaster, it was a lethal, systematic failure of preparedness.
And that phrase, systemic failure in preparedness, that is a crucial thread we have to follow, because the very same vulnerabilities that make a community fragile during an earthquake also leave it completely exposed to the second front of this crisis, the volatile sky. As if the tectonic threat wasn't enough, climate change is now completely rewiring the atmosphere above the Himalayas, and it's creating this dangerous and, frankly, kind of paradoxical situation. So this brings us to a central puzzle, right? How on earth can a region be bracing for more catastrophic floods when at the very same time scientific models are predicting it's going to get progressively drier? It sounds impossible, but this is what experts call the hydroclimatic paradox, and it's the key to understanding the threat from above. So here's how this paradox works. On one hand, you've got the long-term forecasts. They show the region getting warmer and seeing less rainfall overall. But on the other hand, the rain that does fall is showing up in these incredibly violent, concentrated, destructive bursts. Basically, the region is getting less of a steady drizzle and a whole lot more of a fire hose blast.
And this chart, it really drives home that drying side of the paradox. The science is really clear on this. Under what's known as the RCP 8.5 scenario, which is basically a high-emissions future, the projections show a steady decline in the total amount of rain for the rest of the century. And in the long run, that means less water for glaciers, for rivers, and for farms.
Okay, so what about the wetter side of this paradox? Well, that comes in the form of something called a cloudburst. A cloudburst isn't just heavy rain. No, it's an unbelievable amount of water. We're talking over 100 millimeters just dumped in a single hour. Now imagine that happening in Kashmir's steep, narrow valleys. That kind of downpour instantly triggers devastating flash floods and landslides. Now, get ready for this number, 388%. That is just a staggering figure. That's the increase in the area covered by glacial lakes in just over a decade. See, as glaciers melt faster and faster, they leave behind these huge, unstable lakes, sometimes held in place by nothing more than loose rock and dirt. When those natural dams eventually break, you get a terrifying event called a glacial lake outburst flood, or a GLOF. It's basically an inland tsunami of rock, ice, and water.
So, this brings us to what might be the most critical part of this entire story. We've talked about the natural hazards, right? The shaking ground, the volatile sky, but what is it that turns a hazard into a full-blown catastrophe? Well, the answer, unfortunately, is us. Human decisions are acting like a massive amplifier for disaster.
And let's be really clear about this point, because it's so important. Earthquakes are going to happen. Extreme rain is going to fall. These natural hazards, they're inevitable, but the scale of the disaster, the number of lives lost, the number of homes destroyed, that is often a choice. It's the direct result of bad planning, of unregulated development, and of critical failures in how we govern these areas.
Let's just walk through how this works in the real world. Using floods is a perfect example. It all starts with encroachment. Cities expand out onto natural wetlands and floodplains, the areas that are supposed to act like nature's sponges. Well, once you pave over them, that sponge is gone. The river's capacity to handle a surge of water is choked off. So then, when a cloudburst hits, that water has nowhere to go, and it ends up amplifying the flood damage by up to 20%. That's according to officials' own estimates.
In this table here, it just lays out the devastating, real-world cost. It's not just one sector that takes a hit. The 2005 earthquake, it took out schools and communications. The 2014 floods, they wiped out farms and homes. And the constant landslides, they cut off the main economic artery, the NH-44 highway. Each one of these hazards turns into a catastrophe with a massive price tag, both in human lives and in economic stability.
Okay, the situation is grim, I get it. But it is not hopeless. The same science that helps us understand all these risks also points us toward clear, actionable solutions. The key, the real game changer, is to finally shift from just reacting to disasters after they happen to proactively building systemic resilience before they happen.
So what does that path forward actually look like? Well, it's not one single magic bullet. It's a whole blueprint for resilience. First, it's about working with nature, not fighting against it. That means enforcing a Wetland Conservation Act to protect the valley's natural sponges. And it means using science to widen river channels instead of just blindly dredging them. We have to use risk mapping to stop building in the most dangerous seismic and landslide zones. Second, we have to reinforce what's already there. Systematically strengthen critical buildings, our schools, our hospitals, and use modern engineering to stabilize that vital NH-44 highway. And finally, it's all about being prepared. Investing in modern radar is great, but those systems are useless unless they're connected to community drills so people know exactly what to do when that alert comes. It's a combination of policy, engineering, and people.
And so we're left with this final, incredibly urgent question. The science is undeniable. The risks are clear, and they're growing. We even know the solutions. The great challenge now is really one of speed. Can our governance, our planning, and our policies adapt faster than the climate and the geology are changing all around them? Because the future of Kashmir really depends on the answer.